So we want to take a closer look at Boyle's law, and we're looking here to address two main factors. Boyle's law deals with pressure and volume. Now, according to Boyle, he found that these two factors are inversely proportional. This means as one increases, the other decreases. Let's look at the animation. Now, when the temperature is held constant, watch what happens when I decrease the volume of the container. So now, as I decreased the volume of the container, we went from about 0.41, 0.42 atmospheres, and we've increased significantly. If I continue to decrease the size, notice that my pressure continues to go up. Now, you may be wondering, why does this happen? Well, take a look inside the container. As I decreased the size of the container, I started to get more collisions between the molecules. The more they bump into each other, the more they bump into the walls of the container, and the higher our pressure goes. Now, what do you think would happen if I increased the size of the container? Well, as I increased the size of the container, notice what happened to my pressure. I went from my 0.52 somewhere around there atmospheres, and now it's dropped significantly to about 0.35 atmospheres. Now, with more room for the particles to move around, that means that they bump into each other a lot less. This is sort of like moving around the courtyard during the day when there's nobody there or very few people, or when it's packed and everybody's moving trying to get to places. There's a lot more pressure when there are a lot more people in a smaller area, versus if there are less people, it's easier to move, less pressure, and you can get to where you want to go in the end. Now, if you'd like to play around with this some more, go to fet.colorado.edu and you want to go to the gas properties simulation.